very good morning to our lecturer, Dr. Farhana Hani binti Mahmud. We are from Section 2, Group 2, and we are currently presenting about medical imaging and our project. So our group members are me, which is Derek Jeremiah Dave, David Tiong Lung Wei, Frankie Ngarang Sali, and Muhammad Shakir Fahmi bin Muhammad Shah. So I'll be giving the first presentation to my friend.
Okay, thank you, Derek. Firstly is basic principle of MRI. Protons of hydrogen ions in our body are forced to align with the magnetic field created by a strong magnet used in MRI machine. The protons are stimulated and spin out of equilibrium when the radio frequency current is pulsed through the patient, which causes them to struggle against the magnetic field. The energy released as the proton realign with the magnetic field can be detected by the MRI sensors when the radio frequency field is turned off. The environment and chemical makeup of the molecules affect how long it takes for the protons to realign with the magnetic field and how much energy is released. Based on these magnetic characteristics, doctors can extinguish between the different type of tissue. Next is the clinical application of MRI. When frequent imaging is needed for treatment or diagnosis, especially when it comes to the brain, MRI can detect aneurysms and also tumors, as well as distinguish between the white matters and gray matters in the brain. MRI produce images of the brain and other immobile body parts, as well as the anatomical structures that can be kept still, such as the muscle and also the skeletal system. It takes several minutes to obtain each set of the image that is generated. As the result, patients who are unable or unwilling to remain motionless should not go an MIR. So this is the example of the application of MRI. The gray matter of the cerebral cortex is brighter than the white matter. Next is the application of MRI of the knee. The bone marrow is clearly visible in the femur and tibia. Bone cortex is often more easily seen with the CT scan or plain X-rays and is less clearly visible on the MRI. So for the summary of the application of the deep learning, machine learning, and also artificial intelligence, deep learning is a subclass of machine learning. It is based on the neural network that permit a machine or software to train itself to perform tasks. It provides high accuracy output comparable to the machine learning. Machine learning, it is a subclass of AI. It has the algorithm that parse data and learn from it, and then apply what they have learned to make the informed decision, and then get improved with the experience. This category includes deep learning. And lastly, artificial intelligence. The AI sometimes called machine intelligence. It is the intelligence exhibited by the machines or software, unlike the natural intelligence displayed by humans and the animals. I'll pass the next slide to my friend David.
Okay, hi, thank you, Frankie. So my name is David Tiolungwe. So for my task 1, number 3, I choose deep learning as the popular method out of the finding in task 1.5c. So definition of deep learning is a branch of machine learning that work with formula that are modeled after the organization and operation of the human brain. Second is the quality of organized and unstructured data that deep learning system can handle is hung. So next slide. Okay, for the principle of deep learning, do the White sum calculation. Second is the activation function receive the determinate white total as input. So next is the expected output is provided by the output layer. So next slide. So from the diagram, we can see as a cancer tumor detection, caption bot for captioning an image, then continue to music generation and image scanning and object detection. So next slide. So continue to task 1, number 4. Is about explain advantage and limitation of the deep learning. So the main advantages of deep learning is feature are automatically detect and optimally turn for desired outcome. So second is the same neural network based approach can be applied to many different application and data type. Third is the deep learning architecture is flexible to be adapted to a new problem in the future. So next, for the main advantages of deep learning, is require a very large amount of data in order to perform better than other technique. It is extremely expensive to train due to complex data model. Third is there is no standard theory to guide you in this selecting right deep learning tool as it require knowledge of topology, training method, and other parameter. Okay, next. Okay, lastly, the difference between machine learning versus deep learning. So the machine learning is require 1,000 of data point, while deep learning require a million of data points. So the output from machine learning numerical value like a simplification, classification or score. For deep learning, anything for the numerical value to free form element like free text and sound. So how is managed for machine learning? Algorithms are directed by data analysis to examine specific variable in dataset. For deep learning, algorithms are largely self-directed on data analysis once they are put into production. Okay, thank you. That's for me. I will pass to Derek.
Thank you very much, David. So for my presentation is what can you conclude regarding your findings in the task 1.5C? So here the figure shows the fundamental difference between artificial intelligence, machine learning, and deep learning. So the idea of building intelligent machine is known as artificial intelligence, and a subset of artificial intelligence called machine learning facilitates the development of AI-driven application. So for deep learning, it is a branch of machine learning that trains a model using enormous amounts of data and sophisticated algorithms. So next, can the method in task 2, 3 being used to other applications? So the answer to that is yes. Deep learning enables computer to understand unstructured data and create meaningful connections from a wealth of data. Here, a lot of data, powerful hardware, and mathematical algorithms are combined to produce accurate information. Information from digital data can be automatically retrieved, categorized, and analyzed during this technique. So deep learning is already applicable in a variety of applications too, such as voice recognition software, image identification, recognition of objects in a setting, prediction calculations, and deep learning offers great potential for other automotive, medical, and service industries, among the others. So deep learning also has the economic advantages. Deep learning and technology from NVIDIA are being used by more and more businesses to analyze massive volumes of data. So this is all for my presentation. I'll pass it on to my friend.
Okay, thank you, Derek. So, my name is Muhammad Shakir Fahmi. So, I will be presenting about the challenges that could obstruct with the development and the implementation. Okay, deep learning is already applicable in a variety of applications today. Magnet technology has always been a stumbling block for high-speed MRI. Designers have struggled to increase the field strength achievable with a large bore magnet without losing spatial homogeneity, temporal stability, or patient access, as well as without significantly increasing the magnet's weight, price, or fringe fields. The magnet construction must be able to withstand deformation as well as any wire movement, no matter how little. Avoiding coil self-resonance is a key design challenge for high-field RF coils. High-field clinical system raise problems about patient handling and safety monitoring in addition to those raised by conventional clinical system. Next. The powerful static magnetic field will draw magnetic objects, and if those objects become projectiles, they might harm the scanner or injure the patient or medical personnel. Magnetic resonance imaging (MRI), though generally regarded as safe, has a number of safety concerns, including the effects of high magnetic fields and radio frequency pulses on the body and or on implanted devices, the side effect of contrast agents, toxicity during pregnancy, claustrophobia, and hearing loss. Next. From the MRI, the patient may be at danger from the MRI's generated noise. Without the proper ear protection, up to 43% of patients experience temporary hearing loss when they're using the machine. The loud hammering noises produced by the magnetic field as they change over time may cause hearing impairment if suitable ear protection is not used. Furthermore, they may activate neighboring muscle or nerve, causing twitching. So the next part is the final perspective toward the application of machine learning, artificial intelligence, deep learning for medical images. So for final perspective, artificial intelligence that are known as AI or machine learning or anything related to this new advancement are good since it's already been researched for decades, as it will benefit to the economic stances as well as helping the humanity in their basic life. In biomedical research or clinical practice, artificial intelligence models are becoming more prevalent. These models have shown promise in several fields, including risk modeling and stratification, personal screening, diagnosis, including the classification of molecular disease subtypes, prognosis, and therapy response prediction. Next. The application of AI to medical imaging that have been demonstrated so far has demonstrated ongoing advancement in both the use of new technologies for learning, automatic categorization and prediction, as well as taking into account the intrinsic performance attained in many sectors. While the adoption of AI technologies is increasing, challenges still remain. The fear of risk determining how to assess the value the solution will provide, an imperfect grasp of AI, the high cost of technology, and legal, ethical, and security issues are some of the main challenges businesses creating AI solution for social good must overcome. Organizations and institutions may, however, overcome them by funding cutting-edge research, infrastructure, and human resources, as well as through promoting AI literacy in society. Okay, that's all for me. Thank you very much.